Welcome back to the GCSEMathsPro YouTube channel. In this live today is the night before your paper 1 maths exam. We are going to be going through the Edexcel June 2022 paper 1 obviously paper. This is higher tier. I don't think it's 2022, but obviously on the title of the I should say that this is 2022. And I have got the link for this paper and the mark scheme in the description for this live, so if you want to open them up or download them, feel free to do that. So we are just going through paper 1. It's obviously a non-calculator paper for Edexcel, so make sure that you practice this without a calculator, as you obviously will not have one tomorrow in your exam. And as always, if you have any questions, just let me know in the chat, and I can go back through any of the questions that you are unsure of. If there's a part of it that you weren't sure of, just ask me and I'll go back over it. That's absolutely fine. But otherwise, let's carry on. So we have question 1. We need to solve 7x minus 27 is less than 8. So an inequality, just a linear one. Just imagine it's the same as if it equals. I want to get x on its own on one side and then move all the numbers to the other side. So the 27 is what I would move first. It works the same way as I said as any kind of equation. I'm just going to do the opposite, so add 27. You'd have 8, you'd have to add this 27, which is 35. And then lastly, I need to move 7, so I need to divide by 7. That would give me 5. So x is less 5 is your answer. That is literally it, just like any other equation. You just happen to have an inequality symbol there instead. Question number 2, we have to write 124 as a product of its prime factors. So I like to break it down with a factor tree, and I like to just use prime factors. You can use any factors technically, because at the end they will break down into prime factors. I just think it's easier to start off with prime factors. So for example, I like to start off with 2 if it's an even number, which it is. So I'm going to divide by 2 because that also makes the number a lot smaller, breaks it down quickly. So I should get 62. It's still even, so I'm going to use 2 again. I'm left with 31. It's no longer even, so I can't use 2, but actually 31 in itself is a prime number, so I don't need to do anything beyond that. Obviously, just write your answer as the product, so that means multiply 2 times 2, or 2 squared, times 31. It's fine. That is another 2 marks. Question number 3, a delivery company has a total of 160 cars and vans. Number of cars to the number of vans is 7. Each car and each van uses electricity or diesel or petrol. We've got 1/8 of the cars use electricity, 25% of the cars use diesel, and then the rest of the cars use petrol. Work out the number of cars that use petrol. So when you've got this kind of worded question, I just like to work through it more or less in order. So starting off with the total of 160 cars and vans, and then this ratio. I might as well split them up first of all, share out the ratio. So the way that we share out a ratio is we have to add up the parts, which would give me 10. There are 10 parts in that ratio. And then 160 is the total of both. So divide by how many parts there are. That's obviously quite straightforward. It's 16. What that tells me is there's 16 either cars or vans per one part of my ratio. Now, the rest of the question is only talking about cars, so that's what I'm going to work out is the car side, which is the 3 side basically, isn't it? So 3 lots of 16, isn't it? I often recommend for higher tier students to familiarise yourself a little bit with the 15 and 16 times tables, just up to maybe 5 or 6 times each of them, because I feel like it comes up quite a lot in the non-calculator paper, and I just think that then it's easier if you're already familiar, aren't you? You don't have to actually try and work it out yourself. Oh, thank you, Chloe. That's a comment. Thanks for leaving that. I'm glad it's been helpful. Okay, so carrying on, we've got 48 cars here then. That's the total of the cars. So the rest are obviously vans, which I'm not really interested in, am I? Because I've not really mentioned anything beyond that about the vans. So now, carrying on to the next bit of information. We've got 1/8 of the cars use electricity, so 1/8 of 48. That's the cars, right? So 48 Working out an eighth is just divide by the denominator, which is 8, so 6. So 6 cars are using electricity. That's meant to be, oh, that was a horrible T. That's meant to be a T. So I've done that, done this, I've done this, right? You can always tick it off as well. 25% of the cars use diesel, so 25% of 48. The way that I would work that out myself is I would, because I know that 25% is equal or the equivalent of 1/4, I would just divide by 4. If you weren't sure about the conversion into a fraction, that's fine, but you could work it out by doing 10%, so 2 lots of 10%, and then a 5%. However you want to work it out, it might be different to me, that's fine. Obviously, as long as we get the same numbers. So what was that? That was diesel. And then the rest of the cars use petrol, which is the one I'm actually interested in, isn't it? So I've got a total of 48 cars, 6 electricity, 12 are diesel, the rest is what I want to know. So subtract 6 and the 12, which is effectively 18, isn't it? Take away 18, we should get 30 in total, which is cars and petrol. Alright. So it's just a worded question, as I said, work through it in order that they give you the information. I find that that's a little bit easier to organise yourself. And that is actually a 5-mark question, so yeah, quite nice. Alright, question 4, part A. Write 1.63 times 10 to the minus 3 as an ordinary number. So there's 2 ways to do it. One, you just move the decimal place, or if you already know, whenever you have a negative power, that's how many zeros you put in front. So you might find that easier to think about. So either way, if I were to write it like this, when it's a negative power, it's getting smaller, right? So I'm going to move the decimal place to the left 1, 2, 3 times. And then you see how you'd fill in, obviously, a 0 left of that, and then 2 others. So there's 3 zeros in total. 0.00163. That is obviously 1 mark. Part B, we've got write 438,000 in standard form, so the opposite. Now we have to put a number between, I don't want to say 1 and 10 because it's not 10, but 1 and 9.99, so on. Either way, that would be 4, wouldn't it? 4.38. That would be within that range. So the decimal place is currently here. I want to move it to between the 4 and the 3. How many times have I moved it? 1, 2, 3, 4, 5. And because to get to my original number, it would be much bigger than 4, wouldn't it? That's a positive power this time, because my standard form number is smaller than the original. Okay, so it's kind of the opposite of the first one. Now part C, I think, is where it gets a bit more interesting. Work out 4 times 10 to the power of 3 multiplied by 6 times 10 to the minus 5. Give your answer in standard form. Obviously, this is a calculator. If this was in a calculator paper, I would just put it in my calculator straight away and just see what it gives me. We can't do that here. So the way that I split it up, they've obviously put brackets in, but if you think about multiplying, when you're multiplying multiple things, it doesn't matter which order you multiply them in. So what I mean by that is I would pick out, let me get a decent colour, just the 4 and the 6, multiply those. That's quite straightforward, isn't it? And then I would pick out the 10s and multiply those separately. And then at the end I'll bring it back together. So obviously 4 times 6, that will give you 24. And then 10 to the power of 3 times 10 to the minus 5. Do you see how that is effectively index laws? So it's obviously still to the power of 10. I would leave it as 10 to the power of something. I wouldn't literally work it out. And when we've got a multiply here, we actually add the powers. So 3 plus minus 5 would be minus 2. And then you can bring it back together. We're still multiplying those together, aren't we? It's still timesing. So I've got this, okay, but that's not standard form. It kind of looks like it, but it's not, because as we said in part B, it has to be a number between 1 and like 9.999, whatever it is. 24 is obviously not in that range. So you'd have to then convert it into standard form either way. Now it's up to you. You might be able to figure out, okay, I mean, obviously it has to be 2.4, but you'd have to change the power. You might be able to just figure that out yourself. If you can, perfect. If you can't, then what I would do is just literally work this out. Same as standard form, it's telling you when you've got the power of -2, it's saying to move the decimal place, which is currently here, to make it smaller by 2. So actually, this as an actual number is 0.24. And then you go, okay, well, let me put that back into standard form. Clearly, we'd have to move the decimal place once to make it 2.4. But because my original answer here is smaller than the standard form number I've used, it would be a negative power. That is meant to be a nice 1. Not a very good 1. It's meant to be a 1. Okay, well, that's meant to be a 1, right? Negative 1. Okay. So, again, however you want to work this out, you might have done it differently to me, that's fine. As long as we get the same answer at the end, 2.4 times 10 to the negative 1, then that is fine. Okay? So 2 marks for that, 4 marks for the whole question. Question 5, here is a regular hexagon and a regular pentagon. Work out the size of the angle marked X. So with pentagons, hexagons, whatever it is, polygons basically, we have this formula that you might have forgotten about. It's more so a Key Stage 3 thing, but it does still come up in GCSE, where we can work out the degrees or the angles, whatever you want to call it, in any polygon. Now obviously you know a triangle, which should do. Obviously you should know a square, quadrilateral, that kind of thing. But beyond that, you might not have memorized them, which is absolutely fine. So this is our formula, n-2 times 180. That will tell you the angles, total angles, in any polygon. So here a pentagon has 5 sides, n is the number of sides. So for the pentagon, if you didn't know what the total number of angles, or well, total degrees I guess, were, then you could use this to work it out. So 3 times 180, that should give you 540 degrees. So total here is 540. Then the key thing from there are the words regular. That means that all of the sides for each one, you know, they're not the same between them, but they're all the same. So that means that all of the angles are the same, right? They are regular, which means that if my total is 540 degrees, I can work out one angle by dividing it by how many there are, which is 5. So you might want to do bus stop there. You might be happy to. The way I divided this off the top of my head was 500 divided by 5 is 100, and then 40 divided by 5 is 8. So luckily it just worked out quite nicely. That's how I divided it. So 108. This one here is 108. And then I just did exactly the same for the hexagon. Obviously that's then 6 sides, isn't it? So you have to restart. Again, if you don't know the degrees in hexagon, that's absolutely fine. We're just going to work it out this way. So that would be 4 times 180. So what's that? 720. And then, because again it's regular, all of the sides are the same. So therefore all of the angles are the same. So divide that by 6 this time, because there are 6 angles. Hexagon. Then 72 divided by 6 I know is 12, so then add a 0. 20. So this one's 120. Hopefully you can see where I'm going with this. The last bit would be the fact that we've got angles around a point. So angles around a point add up to 360. Take away the other 2, so the 120, 108. Add those together, so that would be what, 228. Subtract that, so you could do obviously column subtraction, but I'm kind of working through it in my head. Take away 200 would be 160, take away 20, 140, take away 8, 132. I'm just going off the top of my head, but obviously you can write it down in your paper if you want to, that's absolutely fine. Okay, 132 degrees should be your answer for X. That was just 3 marks. I have a lot of work for 3 marks, I feel like, but anyway, that is 3. Okay. Question number 6, we have part A, complete the table of values for y equals x squared minus 3x plus 1, so a quadratic. We've obviously got some here filled in for us. Because it's non-calculator, we are going to have to work it out. So effectively just substitute in these values of x. Now if we can find where the line of symmetry is, it might be a bit easier, but yet on that. So let's start with -1. Be really careful when you're subbing in negatives, because when you square a negative, remember, it becomes positive. So that would be -1 squared is +1. Then we've got another double negative here. -3 times -1 is +3. So that'd be 4 plus 1 is 5. That is positive there. Same for 2. That's going to be easier because it's positive anyway. So 2 squared is 4. minus 6 would be minus 2 plus 1 is minus 1. Okay, there's our line of symmetry. There's a little tip here. This is a quadratic. You should be able to recognize that this is a quadratic, which means it's a U shape and it is symmetrical. So can you see how we've come from 5 to 1 to minus 1 again? Then it's going to have to go back up. So it should be 1 here and 5 here because of that line of symmetry. That's a bit of a tip, so you don't have to work out the last two. If you can't find the line of symmetry, then there obviously should be one, but if you're not sure what I mean by that, then obviously just go through and work them all out individually. So substitute in 3, substitute in 4, you'll get the answers the same. It's just a little bit of a trick there. So 2 marks. Now, actually, I do need to see that. So on the grid, for part B, on the grid, draw the graph of y equals x squared minus 3x plus 1 for the values of x from minus 1 to 4. So that's the same thing, isn't it? So your table here, you would just fill it out. So minus 1, 5, 0, 1, 1 minus 1, 1 again, up to 1 again. You see where this is where it's going back up again. There. Now, use a pencil when you do this, just in case it goes really badly wrong. You need to rub it out and try again. We need to join these up as as smooth as possible. Smooth curve. Now, I'm going to attempt it the best I can. Digitally, it is a little bit easier, obviously, in front of you on a piece of paper. So mine is going to be really wobbly. Actually, I don't know if I had a way to do this. Oh, let me try this because my actual drawing is... Oh, that's way better. Yeah, there we go. That's way better than me trying to draw myself. Actually, might make it a bit thinner just because I think we need to use it in part C. Yeah, there's part C, so I'm going to do this again, but I'm just going to make the line thinner so that we can see. Okay. It's accurate. So I realise, you know, in person, when you draw it yourself, it won't be super accurate, but try and make it as accurate as possible. Okay, that's pretty good. You can see also here where it was minus 1, don't obviously draw a straight line across, like it still carries on technically lower and then goes back up again. Okay, part C, using your graph, find estimates for the solutions of the equation x squared minus 3x plus 1 equals 0. This is really easy. Easiest 2 marks yet. So just as a quick explanation what this means, did you see how originally we had x squared 3x plus 1, and here we have again x squared minus 3x plus 1. That has not changed. What has changed is originally we had y on the other side. Now we have 0. So that means we're looking at when y is 0 on this graph. Now where is y 0? That would be here, this line, the x-axis effectively. That is where we're looking at. So you just have to see where it crosses. That's why they've said solutions as in plural, because obviously it crosses twice. You see here, colour, here and here. So just read it off the best you can. This is why it's important that you try to get your part B curve to be as accurate as you can. Obviously, I know it's not going to be fully accurate, but just roughly as accurate as you can so that your answer to part C is within the range that they've offered. So what have I got here? Check the scale. That seems like every small square is 0.1. So I think I would say 0.4 for that. The first one. X is 0.4. And then the other one here, 2.6, I would say. Now, because obviously your curve, my curve, everyone's curve will be slightly different because you're doing it with pencil. You obviously have to go through the same coordinates, but it's still going to be slightly different, isn't it? There will be a variation. They have given a slight range of possible answers. So their range was 0.3 to 0.5 for this one. So if you've got anything between those or including those, fine. They will give you the mark. And then for the second one, 2.5 to 2.7. So it's not a massive range, right? But it is a slight range. So as long as you've got something between those two ranges or including the numbers there, then you get both marks. Obviously 1 mark for each number. We don't need to write down what y is because A, the actual equation they gave us only mentioned x, but b, technically we know that y is 0, so it's implied. So that's another 2 marks, 6 marks for all of that question. Question 7, here are 2 cubes, A and B. Cube A has a mass of 81 grams. Cube B has a mass of 28 grams. Work out the density of cube A to the density of cube B. Give your answer in the form A to B, where A and B are integers, i.e. whole numbers. You can also see that we've got cube A has a side length of 3 and B has a side length of 4. So this is screaming to me we've got mass, they've mentioned density, and technically we have enough information to work out volume. So I'm thinking density is mass over volume. You have to memorize that formula. They won't give it to you. As you can see in the question, it's not given. I like to use it as a formula triangle. We are looking for the density, so I need to have the mass, which I've got, perfect, and that then tells me I need to work out the volume for A and B. So that's where I'm going to start. The volume of A is a cube, so you're just multiplying 3 by 3 by 3, aren't you? 3 cubed. So we should know that that is 27. Then we'll do the same. 7, it's not a nice 7. 27 meters cubed. The volume of B is 4 times 4 times 4, or 4 cubed. You should know is 64. Yeah, your answer is looking right, but we'll get to that. But yeah, it looks like you're on the right lines there. So we've got the volume for both. We've got the mass for both even. So the density for A, we separately, density is mass over volume. So for A, 81 divided by 27. They've chosen these numbers deliberately. We are, again, in a non-calculated paper. They are, well, at least it's question 7, right? They're going to choose nice numbers, at least for this bit, I would say. So 81 is a multiple of 3, hopefully we know that. And 27 is a multiple of 3, we've just seen that. So that should help you work out that when you divide it, it is just 3 grams per centimetre cubed. That's just the units. Same for the density of B. We're going to take 128 over 64. They've chosen these numbers again deliberately because they're both, I guess, 4, whatever you want to call it. They divide and they give you 2. They divide quite nicely, if that makes sense. There's not any decimals, what I'm trying to say. So we've got that. The density of A is 3. The density of B is 2. So they just want 2, basically. That's all they wanted. Where they're whole numbers, I've got whole numbers, so that's fine. So yes, you were correct. 3 to 2. How many marks do I need to get in every paper to get a grade 6? I think I have a video on, I don't have it off the top of my head, but where I went through, or I briefly mentioned the average grade boundaries, like I'd worked it out myself over the last few years, for like grade 9, grade 8, grade 7, 6, 5, 4, so on. That's one of my most recent videos. I'm trying to think which one it is, because I can't remember what the numbers are off the top of my head. It's a lot lower than you think. Yeah. I don't think it'd be higher than 60. Probably much lower than that. But yeah, it's not that high if you're on high work. Yeah. Yeah, I can't remember which video it was, but it's one of the videos where I'm like, it's not like a voiceover like this, it's like an actual kind of sit down, face the camera video. I brought it, I think I dated it. It might have been the one that went up 2 days ago, like a 7-minute video. You can have a look at that, it might be that one. Or if not, I think I've only got 5 or 6 sit down videos you can have a look through, because I do kind of put it on the screen like a little screenshot, but I can't honestly remember. Yeah, have a little look, but it might be the one from 2 days ago. If not, then there's some from last year, where I definitely briefly kind of mentioned the fact that the grade boundaries are lower than you would expect. So yeah, be there somewhere. Unless I have the spreadsheet here. But yeah, it's definitely a lot lower than what you'd imagine. That's what I said. How to stop making random mistakes on questions. Yeah, work slower. That's a really good tip. Try to not rush. You've got about a minute per mark, so if you're working at that pace, perfect. If you're going faster than that, you don't necessarily need to go that fast. But also, if you do a minute per mark, you get 10 minutes at the end. That will give, like, let's say you did stick roughly on that, you'd get about 10 minutes at the end to go back through the paper. I know at the end of once you finish the paper, you can't, but like use all the time they give you back and look and double check all of your calculations if you can. But yeah, just try to be really intentional. Also, I'd say think when you get an answer, think about it. Does it make sense in the context of the question? Because sometimes you get an answer, let's say like, you know, when you have Pythagoras' theorem, you might forget to square root at the end. And if you look at your answer and go, well, this answer is way like much bigger than the other sides of the triangle, then you can go, hang on a minute, something's not right here. Oh wait, I forgot to square root it. That kind of thing. Just try and think about, you know, does my answer actually make sense to the context of the question? Sometimes it can give you a clue as to whether you think my answer doesn't really make sense. What might have gone wrong and then mistake. Yep. How many marks to pass foundation? Yeah, foundation is much higher because obviously you only go up to a 5. A pass is a 4. In probably about 70%. Again, I can't remember off the top of my head. It is on that video I mentioned earlier. It does mention grade 4 and grade 5 foundation as well to pass. Yeah, probably about 70%, I would imagine. It's a lot higher than higher tier to pass. Just check before we go on. Yeah, again, how many marks you want to guarantee? Get an 8 or a 9. I have to find that spreadsheet. At least for Edexcel. I do have it there. But I can't remember off the top of my head. I mean, at least 10 on each paper, I'd imagine. But don't take my word for that. I need to double check it. Yeah, the end of the paper. Yeah, obviously that's the harder stuff because then it is the grade stuff, isn't it? Your grade 5, you want to get to grade 7. I think it's possible. Obviously, there's, you know, tomorrow is tomorrow, right? Whatever happens tomorrow will happen. But you've then got another 3 or 4 weeks for paper 2 and paper 3. It depends if you're going to commit to maths or if you also have a lot of other subjects that you need to put time into. That's the issue. 3 or 4 weeks for maths, if that was your main focus, then yeah, sure, I'd imagine that you could do that. But if you have to also focus on English and science, and all, it depends on priorities, doesn't it? Depends on how you allocate your time. Okay, right, I'm going to carry on just so that we get through the paper, and I'll see if I can find that spreadsheet later. So, question 8, the table shows the amount of snow in centimetres that fell each day for 30 days. So we've got a frequency table, work out an estimate for the mean amount of snow per day. This is just mean from a frequency, right? So if you know how to do this, it's the same for every question. Quite nice. So what we have to do is, because we have ranges here, you have to have another column. I'll just write it up here, which is the midpoint of these ranges. Now, here it's probably quite obvious what the midpoint is, but just for other questions, whenever you're trying to find the midpoint, if you're not sure, like if it's not obvious to you what it is, you add both of them together and you divide by 2. That will always give you the midpoint. It also works for like coordinates and things like that. So we can see here though, hopefully see that that's 5, 25, 35 and 45. And then you want another column, which is the frequency multiplied by the midpoint. So these two multiply together. So 8 times 5 is 40. 10 times 15 is 150, I was going to say. 7 times 25 is 175, I think. 2 times 35 is 70. And 3 times 45 is 135. Yes. Once you've done that, so that's kind of like, that's step 1, that's step 2. Then you have to add this column together for step 3. So add all of these up. So I've not drawn them very much in line, have I? But see, 5 and 5 would give us 10. Then we've got 10 here, 17, 22, 26, 27. Yep. 7 here, 0. A 2 there. 1. 7. Oh, don't count the 7 again. This is why you got to line it up properly. Don't count the 7 again. 100, 200, and 300, 500. Okay, however you want to add it up. It should be 570 though. There we go. Now, your final step is working out the mean, where you know when you add them all together, divide by how many there are. We've just added them all together. That's what we've just done. Divide by how many there are. Now, if you don't know that, you can add up the frequency column, but they have told us that it should be 30. Divide by 30, which means I can knock off the zeros. 57 divided by 3. You could do bus stop, however you want to divide it. Oh, it started raining. Hopefully that's not too loud for you guys. It goes in, what, once, Remainder of 2, then 27, that would be 9. 19. There we go. 19. Whoever said, someone said in the chat that it was 19. You are correct. It is 19. But yeah, you just follow those steps every time. That's why I quite like it. Let me have a look. You got 19. Yes, you are right. You also got 19. Perfect. Yeah. What do you do if you finished every past paper 1? Well, perfect if you have. I mean, if you have, that's the most ideal scenario to be in. Oh, you actually did class width. Yeah, class width is to do with histograms. It's a completely different topic. It's still a frequency table, but it is a completely different topic. Yeah. Oh, yeah, I also have a predicted paper. I don't know if you've seen that. It uploaded, I think, yesterday. If you just go onto my channel as an actual video, not as a live, I have got my own predicted paper, which you can have a look at. Or just Google someone else's predicted. That's also fine. Okay. Right. Question 9. A cube is placed on top of a cuboid, as shown in the diagram, to form a solid. The cube has edges of length 4 centimeters. The cuboid has dimensions 7 centimeters by 6 centimeters by 5 centimeters. We can see all of that from the diagram. Work out the total surface area. Okay. So surface area is just all of the areas of all the faces, but on the outside, right? So this kind of bit here, where it overlaps, is not going to be counted. We just want the outside. So I'd probably, you can start wherever you want, but I'm going to start with the box, well, cube, if you want to call it that, box on the top. So the surface area of that, to find out one side, is 4 times 4, isn't it? Length times width, they're both 4 because it's a cube. So 4 times 4, and then normally a cube has 6 sides, but as we said, we're going to ignore this one here. We don't want that one because that's kind of inside. So there's 5 other sides on the outside of that. 4 times 4 is 16. You see how we've got that 16 again? I was saying at the start that I think it's a good tip to be familiar with the 15 and 16 times tables, because I feel like they come up a lot in non-calculated papers, and it's just a bit easier, a bit quicker if you've already got it on the top of your head, isn't it? So 5 times 16. What you can also do with a 5 is just multiply by 10 and then half it. Also do that. Four times 4, there's 5 of them. So we say 80. Squared. Okay, now the bottom one, so that was the top one, right? The bottom one, there's a few more, because it's a cuboid, we've got different dimensions. So the front and the back would be 7 times 5. The front and the back, there's 2 of them. Add that to, let's say, the left side and the right side. 6 times 5, there's 2 of those. Times 5. Add that to then the bottom, which is 6 times 7, and then this top bit is also 6 times 7, but as we said, we keep saying this, we don't want this bit here. So that bit we know is 16, don't we, from the previous one? So we want to add, I guess, well, yeah, you could add 2 of those, and then you can take away the 4 times 4 in the middle, the cutout bit. So we've got, what, 35, so that's 70, plus here we've got 30, so 60, plus here we've got 42, so what's that, 84, and then take away 16, 130, 214, 198, so I'm just saying numbers, but that's just me working out. Obviously you can work it out using whatever method you like. If you want to do it on top of your head, fine. If you want to use column addition, column subtraction, that's fine, but you should get 198 for the bottom one. Now we're just adding those together basically, aren't we? Total surface area would be those 2 added together. Should get 278. You might have done it in a different order to me, that's fine. Again, as long as you get 278 at the end, then it's fine. That's 3 marks. Okay, let me have a look at. Okay. Yeah, you got 278. I haven't seen her predicted paper. I'm actually gonna have a look at it. Is it really good? I'll have a look. Okay, cool. Next one. Question 10. So the table shows some information about the profit made each day at a cricket club on 100 days. So again, we've got another frequency table, but in a different context now. We've got to complete the cumulative frequency table. It's only 1 mark because it's really straightforward. All we're going to do is just add them up. So for example, the first row is exactly the same. You can see it's 0 to 50, 0 to 50, exactly the same. But then the second row is now 0 to 100. So that includes the first 2 rows up here, which is then 5 if you add it. You see what I mean? Every time I'm going to add another one. So add 25 here, which is 50. Add 30, which is 80. Add 5, 85. Add 15, 100. And your final row should add up. If they have told you in the question what the total is, it should add up to that. If it doesn't, there's something wrong. So that's 1 mark. That was pretty straightforward. Part B, on the grid, draw a cumulative frequency graph for this information. So obviously I need to have a page. You will have it on the same page, but obviously when you open your exam paper, it'll be 2 A4 sheets, so you'll be able to see it on print screen if I can, and copy it over. Yeah, so we can see it here. Okay. Now, for cumulative frequency, we do not use the midpoint, where we have to try not to get confused between all of these different versions of frequency tables. We're not going to use the midpoint. We are just using these numbers on the right-hand side of your ranges, okay? So the first one would be at 50 along and 10 up. So, yeah, accurately. 100 and then 25. Be careful of the scale. This is here is not 25, it is 30. So 25 would be in the middle of that. About there, obviously on the 100 line, ideally. 150 would be 50, which is here. Then 80. Should be constantly going up if you're doing a cumulative frequency graph. The whole point of the word cumulative is it adds and adds and adds. It carries on going up, doesn't it? 250, 85. So again, be careful because this is 90, so halfway. Always double check the scales of all of your graphs because they tend to change. They might not be what you expect them to be. And then obviously the last one should be 100. Okay. Okay. So I'm going to attempt at least to draw a nice smooth curve. It's not a line graph in terms of a straight line. Something like that, you know, roughly. Again, with a pencil. Okay, part C. Use your graph to find an estimate for the number of days on which the profit was less than £125. So I'm going to get, well, you would get your ruler, right? I'm going to get my straight line. £125 on my x-axis is here. And then across. Yours might be slightly different answer to mine, obviously, because we will have drawn our graphs a little bit differently. We should have the same coordinates again, as we mentioned before, but no one can draw it the exact same pencil. So what have I got? I would call that 36. Now they have given a slight range, as always, because it is slightly variable. So as long as you get anywhere between 35 and 39, then that is fine. So I'm kind of on one end. Yeah. Just look at the chat. Yeah, I think it's a bit quiet, isn't it? I don't know if that's just my settings on the microphone. It might be something I have to look into for when I do paper 2 and paper 3 as well. I'm not really sure why it's so quiet for you guys. I'm trying to speak a bit louder, I guess, or I'll get a bit closer to the microphone. But yeah, that's something I'll definitely look into and I'll try and fix for next time. It's really quiet. Part D, use your graph to find an estimate for the interquartile range. So interquartile range is when we work from the y-axis. That is the upper quartile minus the lower quartile. The upper quartile is the equivalent of 3/4 or 75%, however you want to think of it, of the total, which was 100, wasn't it? So 75% of 100 is just 75. So again, be careful. This is 70 here, so 75 would be like halfway through this square. And then down. What would I read that off as? That's 175. Each square on this x-axis, I think it's 5, isn't it? 55, 60, 65, 70, yeah, 75, 80, 185, I would say. That's what I've got, 185. And then we want the lower quartile, which is 25%. So 25% of your total cumulative frequency. So 25 in this case. Straight across. I think that was actually one of our numbers. I'm just looking at it now, isn't it? So that should be 100. I guess everyone should get 100 for that, right? Because that was actually one of the coordinates. So 100. And then the interquartile range is where we subtract them. So 85 is what I have got. Now, what's their range? They've said you could get anywhere between 85 and 93. So that tells me that mine would, while mine is correct, I was quite close to the edge of that range. So hopefully you'd get something a bit higher than 85. Yep. Okay, let me have a look at the chat again. How did I do C and get 36? So C is the purple line. Right, do you see I've gone here, which is 125, as they said, £125. I've just drawn a line up at 125 until I hit my graph, and then I went across and I read off the number here, which for me was 36. As I said, it might be slightly different to you. As long as you've got somewhere between 35 and 39, then you should be okay. Any other questions on the whole of, what was this? Question 10. Yeah, okay. Let's move on. I'm just having a look into if I can change the microphone thing whilst I'm doing this. I think I can change it in settings, but I don't know if that would actually take effect whilst I'm currently using the microphone, if you know what I mean. So, quick look if I can do anything right now. I could add a filter on it, we could try that. Let me try and add a filter really quickly to this microphone. Makes it louder, and then I'll fix it for the next live. Okay, I'm adding a little bit there, so you tell me if that's louder. If it's still not loud enough, I can add a bit more. You just guys let me know in the chat. Okay. Look, we've got any more questions before I carry on? What grade was the question? I'd say about a grade 6. That's just my kind of estimate. That's not necessarily factual, but that's my estimate. Okay. So when you use the midpoint for a graph, that is for the frequency polygons. It's a very specific topic, but again, it comes from a frequency table. They're all stemming from frequency tables. That is where you use the midpoint, okay? All right, so Cormac has some sweets in a bag. The sweets are lime flavoured or strawberry flavoured or orange flavoured. In the bag, the number of lime sweets to the number of strawberry sweets to the number of orange sweets is in this ratio 9:4 to x. So I like to just label it like this. That's just my personal preference, so I can quickly refer back to it. Cormac is going to take at random a sweet from the bag. The probability that he takes a lime flavoured sweet is 3/7. Work out the value of x. Okay, so what I did was because they've given us x, I'm thinking, right, I need to set up an equation. That's what I would like to do. So probability of getting probability lime, I know is 3/7, but I'm going to put something here with this ratio. So because probability, you can use a fraction, can't you? See, there's a fraction here. I can convert my ratio into a fraction as well, and then I can make them equal to each other. So the probability of picking lime would be, if I were to convert this ratio into a fraction, but for the lime section, would be 9. See, lime is the 9 one. Out of, and then you, when you're going to create any kind of fraction from any kind of ratio, you add them all together to put in the denominator, don't you? So 9 plus the 4 plus the x. And then that would equal to 3/7. So do you see how I can create an arrow? I can create my own equation just by doing that. Now all I need to do is solve the equation, because all I want to do is work out x. So we've got, obviously add that together. That'd be 13 plus x, wouldn't it? Which at the same time is equal to 3/7. I would probably cross multiply. What I mean by that is multiply by the denominators. You can do it in 2 different steps separately if you want. I like to just do it in 1 step. So 9 times 7, we should get 63. And then on the other side, you're kind of expanding a single set of brackets. So that'd be 3 times 13, which is 39. 3 times x, which is obviously 3x. So do you see where I'm going with this? Now it's just basically a very straightforward equation. I'm going to move 39 by taking it away. You should get 24 is equal to 3x, and then divide by 3. 8. That's what I would have done for that, is just creating an equation and solving it. Okay, let's look. You got 134. Yeah, see, that's the thing, because if you think about it, right, you know when I was saying about how can you pick up on if you've made maybe some small mistakes, and if your answer makes sense? Well, if you've got 9 lime sweets, 4 strawberry sweets, then orange, even if you don't know what it's going to be until the end, you can kind of guess it's going to be in the ballpark of this, isn't it? Maybe maximum like 15. But if you get 134, do you see how you might think, well, surely that doesn't make sense because of the context? Like, if I've got 4 and 9, then why would I have 134 of another? Do you see what I mean? Like, you can kind of have a look at your answer and go, does that make sense? In this case, I would say, hang on, something does seem a bit off there. Like, it seems too big. Why is it equal to 3/7? Because they told me here that it was equal to 3/7. That's where I got that information from. What do I mean by cross multiply? So I just did it in 1 step, but I can go over it kind of in more detail if you'd like. 9/13. I'll just rewrite it here, and then if I were to do it in more steps, right? I obviously, in order to solve it, I don't want fractions, because that's quite like kind of annoying, but also I don't want x in my denominator. That's also very annoying. So let's say I wanted to get rid of the fractions. The way when I say get rid of fractions, I mean you multiply by the denominator. Now obviously you have to do that on both sides. It's technically like multiply by 13 plus x on that side, and you see what I mean, same on this side. Multiply by, oh, that's meant to be a plus. Actually look like a plus. Okay. And then you see how if I multiplied the left hand side by 13 plus x, it would cancel out the denominator. Great, that's what I wanted to do. I don't want it as a denominator, but it still has to go somewhere. It's not just going to be disappear. Is now here, and then I can multiply again by 7 to get rid of that denominator, which would obviously multiply by 9, 63, and I end up with this. Do you see what I mean? I just did it all in 1 step. That's when I say cross multiply, I'm multiplying across on both sides. I just did it in 1 step. If you want to do it in 2 or 3 steps, that's absolutely fine. And then I obviously just, do you see what I mean? I expanded those brackets. How do you remember to put it into an equation? I would say 2 things. 1, for me personally, I quite like algebra. So when I have questions, I kind of naturally tend towards, oh, can I make an equation here maybe? But the other thing is the fact that they've given you x. Whenever they've given you x, or they've said work out x, the only way you can work out x is if you have an equation. You know what I mean? Like, it's telling you, oh, you could probably use algebra here. That would be like the most ideal way to do it. That's the kind of hints that I would take from that question. Yeah. Yeah, so how is 42% equal to the ratio? Because I guess it'd be 9 to 4 to 8, and 9 is 42%. If you were to work it out, you don't have to obviously work out percentages in this question at all because it would take too much time. But yeah, just so you get what I'm saying, 9 out of, well, what would that add up to? 30. 9 out of 21 is 42%, I'm assuming. Never actually worked out as a percentage, to be fair. Yeah, 42.85. Okay, someone asked me to go through it again. I went through kind of half of it again. I don't know, do you want me to go through like where I've got this bit from? Because I guess that's the key bit. You just let me know. Isla. First 15 questions. Yeah, normally how many questions are there? Kind of maybe 21 to about 24, 25 on average. It does change, obviously. Sometimes it's fewer. Okay, as long as you've understood, that's perfect. So 15 out of, let's say, 22 questions, but then a lot of the heavier marks towards the end. I don't know, it might be close. Again, I can't remember exactly how many, what the average was for a grade 7. It's obviously lower than you might think, but yeah, you're still cutting off quite a few questions at the end, aren't you? Okay, question 12, express 0.117 recurring as a fraction. So this is just, again, if you've memorized the method, then you can just apply it. It's quite nice. So I always say let x, you can use any letter you want, but x equal the 0.117 recurring. Do you see how just here, the clear thing is that this first one is not recurring, it's then the second 2 digits that are. So we want to isolate the recurring part of the decimal. So I've kind of got 2 steps here because, as I've just said, one of those numbers is not recurring. So I want to get it out of the decimal. So I would do 10x because that will move my decimal place along by 1. And now do you see how I've isolated the recurring part in the decimal? Then you need 2 versions of this. So we've already got one here. I need another version of this with the exact same recurring decimal in the same order. So that would be kind of moving the decimal place twice more, wouldn't it? Which is multiplying by 100, but we've already started with 10, haven't we? So that's actually 1,000. X would be 117.17 recurring. So you see how I've got exactly the same recurring decimal. That's what I want. And then you subtract them. So that would be 990x. Over here, obviously the whole point is that when I subtract them, the recurring decimals cancel. But don't forget that you do need to do 117 minus the 1 that's still there. That'd be 116. Then we're going to solve the equation. So divide across by 990. Now, that's a fraction. They said leave it as a fraction. So you can leave it like that. They haven't told you to simplify it, so you can. But yes, I've seen someone said in the chat, yeah, you got 58 over 495. Exactly. It would simplify if you divided by 2. You don't have to because they haven't said you have to, so it's completely up to you. You know, just make sure you read the question. If they tell you to simplify it, then obviously do. If they give you an answer that you have to match, then you might simplify to get to that matching answer. But in this case, technically, they'll accept 116 over 990, or they'll also accept 58 over 495. Kind of any equivalent is fine. Yeah, this one's quite a nice one if you know exactly what to do. Is there another difficult ratio question? Because we're going through this paper, I don't have any others, but I'm pretty sure I have a video, as in not a live, but an actual video where I've done the hardest ratio questions. I think I have. So you could always have a look on my channel and have a look at those because, yeah, I go through all the Edexcel, the hardest, what I deem as the hardest ratio questions. And that might be helpful to you. That's 3 marks for question 12. Question 13. So a right-angled triangle is formed by the diameters of 3 semicircular regions, A, B, and C, as you can see on the diagram. We need to show that the area of region A is equal to the area of region B plus the area of region C. Now, this one, this is where you might be like, okay, I don't really know where I'm going with this because it's a prove kind of question, isn't it? But yes, this is a higher tier. So because we've got a right-angled triangle and we've clearly got diameters that are the length of all the sides, I'm kind of leaning towards Pythagoras just from the context, if that makes sense. So I think there's different ways to do this. If you have a look at the mark scheme, there's different ways to lay it out. You can also use numbers, that's fine. I'm going to use, I think, letters. I would use A, B, and C, but obviously Pythagoras' theorem itself is A, B, and C, so it's a bit confusing. So I think what I saw in the mark scheme that was suggested is that you could use X, Y, and Z, but whatever letters you want. You can also use, as I said, actual numbers. It's fine. I'm going to do it this way. That's just the one that I thought made sense. So we obviously know that Pythagoras' theorem is true. We're not trying to show that. That's just a true fact. So we know that x squared plus y squared should obviously equal z squared. But also they've talked about areas, haven't they? So we might as well also use areas. So from a second, I'll just pull it to the side. The area of semicircle A, so a circle is pi r squared, isn't it? Pi r squared, but it's a semicircle, which is half, so over 2 or multiply it by half. Now the diameter, because z I've labelled as the side length, right? So the diameter is z, so therefore the radius is half of z. So you've got to be a little bit careful. Half of z is the radius, isn't it, squared? But because it's a semicircle, I also want half of that. Now that looks a bit confusing. That's meant to be a z there, and that's a 2. The difference there. So hold on to that for a second, and then you can do the same for B and C. So the area of B would be pi times the radius, which is half of x squared, and then over 2 because it's only a semicircle. And the same for C. So y over 2 is the radius squared over 2. Okay, we've got those. Now what we can do is, because we're basically saying that when you add them together it should equal to area A. If I add those and then we'll simplify it, hopefully we'll end up with this, is what I'm aiming for. Over 2 plus the B one, which was x, didn't I? Oh, hang on. I'll put x first just so it matches this. And then, where's my pi? Yeah, it's a really tricky one, this one, I feel like, for question 13 as well. Y over 2. And that should equal the bigger one, right? The z one. Z, try and make that clear that that's a z, not a 2. Over 2. If I were to simplify this equation, we can easily cancel out the pi's, right? If you were to divide across by pi, it would cancel out, wouldn't it? Get rid of those, that's kind of irrelevant. If I were to multiply across by 2, the whole equation, it would cancel out those denominators, wouldn't it? So just cancel those out, get rid of those. Now, if we actually square these, we get x squared over 4, because remember you'd have to square that too as well, plus y squared over 4 equals z squared over 4. And then do you see how, again, if I multiply across by 4, it would cancel them all out? You see how I've ended up with the same thing? And that basically proves it, because you've started here and then we've ended in the same place. Yeah. Let me have a look at the chat. Yeah, this one is a really tricky one, I honestly think. And also, you know what the good thing about this one though is like very niche. It's very specific. It's unlikely you're going to get exactly this type of question again. You know what I mean? So there are some questions where you go, do you know what, that doesn't make sense to me. So I'm going to try and get however many marks is it? How many marks is it? 3 marks. It's only 3 marks. You might think, well, I'm going to just try and get 3 marks on a different topic that is more predictable. You know, one that you can revise, and if it comes up, you'll actually be able to apply it, rather than this one that's such a random question, really, isn't it? Like a proof kind of question. I wouldn't necessarily worry. Hang on, you've asked a question about the recurring decimal. Why, when it's 1000x, is recurring on the last 17 rather than in front of the decimal? Because you only have recurring in terms of decimals. There's never recurring in terms of whole numbers, like units, tens, hundreds. There's never recurring parts there. It's always just decimals. So I didn't draw it on the 117. It's out of the decimal. Yeah, how is this question 13? I agree. As I said, there are quite a few ways to do it in the mark scheme. You might have a look at the mark scheme and actually decide that you prefer a different method. That's also absolutely fine. What kind of makes sense in my head would, could be different to what makes sense in your head. That's absolutely fine. So they've given, what, 1, 2, 3? They've given like 3 or 4 different ways of doing it. So it doesn't have to be my way. That's the one that when I looked at the mark scheme, I thought, okay, that kind of makes sense to me. You might prefer a completely different method. That's fine, but that's why I think it's quite good to look at the mark schemes, because you can pick up on how they've suggested to answer it. I have linked the mark scheme in the description of this live as well, so you can have a look. What is this topic called? Yeah, I don't even know what you call the topic, because proof, I guess proof overall, because it's saying show something, but you have got a bit Pythagoras in there, you've got the area of semicircles. It's not really one topic. That's why I think it's quite hard as well. It's not one topic that gets repeated over and over. It's a combination of multiple, isn't it? Are you supposed to be specific about the wordings of circle theorems? Yes. Yeah. I would say. Is capture recapture on here? I don't think it's on this paper, no. I have got a video on it though. You can have a look at my video separately to this if you like. I'm going to move on just because I think there's no point going in detail over this question. As I said, it's unlikely to come up exactly the same again. This was also 2022, so it's kind of far away. So I wouldn't worry if you feel like that doesn't make sense. You can have a look at the mark scheme yourself if you like, but it's not a topic that repeats itself exactly the same every time. So I really wouldn't stress about it. Question 14. This one is a much better one to know how to do. This one does repeat, I feel like, itself. So here is a speed time graph. Part A, work out an estimate of the gradient of the graph at t is 2. So where t is 2 on the x-axis here, when it says work out the gradient at a specific point and it's obviously a curved graph, this is the one where you have to basically do a tangent, draw a tangent. Now before I draw a tangent, what I would recommend is you write down the exact coordinates of, well, in this case, t being 2. So we've got 2, and then what is that exactly? Because obviously your tangent is meant to go through that point. So that would be the most accurate point along your tangent, wouldn't it? Because everyone's tangent is slightly different. So I would use the set of coordinates that they've actually given you. So then at least half of your coordinates are accurate. So 2.8, I would say, for that. Now draw your tangent. So it's meant to be a straight line. Let me make it back. A straight line that kind of comes along, it just skims along, it touches ideally at 2 and then carries on. That's kind of the idea. Obviously use your ruler and pencil so you can rub it out if you need to do it again. I'm just going to kind of give it a few goes. See, that to me I think is, do you see what I mean? That's too slanted, so move it again. You can obviously move your ruler around a few times until you're happy. Not quite. I'm just going to keep moving it until I'm getting something that I like. No, still not quite. It needs to be a bit... No, I've gone past it now, see? Gone past it. Not quite as slow. There? It's much harder digitally, I think, but I think that's a bit further. See, I could play around with this all day until I get something that's accurate, but I'll try and... I don't think that's very good, but we'll go with that just so I'm not here for 5 minutes messing around with it. Maybe there. So I've already got my set of coordinates, right, that was on the point, which is the most accurate. And then what I'm going to do is, because we have to find the gradient of the tangent, right, straight line. So you need 2 sets of coordinates. That's why I chose one set of coordinates that was exactly on the point I was supposed to technically have my tangent. My tangent I don't think is very accurate, to be honest, now that I'm looking at it. But now I'm going to choose another set of coordinates. You could choose obviously the one where it goes through 0. Which one is a nice set? Maybe here I've got 4.8. That's what I've got. As I said, I don't think this is a very good tangent, to be honest with you. So we'll see if my answer is even in the range of what they've given as a suggestion. But we want to find the gradient of the straight line. So remember, gradient of a straight line is change in y over change in x. It doesn't matter which way round you put the coordinates, as long as you obviously put them vertically correct. So as in, this is y, this is y. If I put 4.8 first, take away the other 2.8, then I'm going to put the matching x coordinate vertically there. Do you see how that matches? And then the 2 goes with this one. Just so that you get the right positive or negative. If I subtract that, that gives me 2. Oh, I've got 2 over 2, which is 1. I've got 1. Now let me actually have a look at what the answer should be, because I don't know if that's even close to being accurate. Oh yeah, okay, that's fine. So my answer was 1, but obviously because everyone's tangent will look slightly different, they have given quite a good range. If you get anything between 0.7 and 1.1, I was within that range, so I've got the 3 marks there. If you're in that range, you also get the 3 marks. Don't rub out your tangent, because they're going to want to see it as part of the marks. Just leave it where it is. But that's it for that one. And part B, what does the area under the graph represent? So the second kind of half of that topic is finding the area under the graph, but remember what that means. If it's a speed time graph and you're doing area, you're effectively multiplying those together. When I multiply speed and time, it gives me distance, doesn't it? If you think about formula triangle, speed equals distance divided by time. So distance equals speed times time. So the area under a curved graph where you've got speed and time is just distance. That's it, distance, 1 mark. Right. So that is 4 marks in total. This is a question that's more likely to repeat itself, right? So it's helpful to know, okay, I need to draw a tangent, find the gradient, so on. Okay, 15, now we are on to vectors. So A, B, and C are 3 points such that AB is 3A plus 4B, and AC is 15A plus 20B. Prove that A, B, and C lie on a straight line. 2 marks. Okay, proving that they lie on a straight line is really straightforward, again, if you know how to do it. If you remember, like, just memorize it, right? To prove that 2 vectors lie on a straight line, they have to, first of all, be proven to be parallel. And what does that mean? That means that they have to be a multiple of each other. So is one just a bigger version or a smaller version of the other? What you're going to do is compare the coefficients. What I mean by that is the numbers in front. So for A, and then separately for B. The scale between them should be the same. So for example, if I do 15 divided by 3, that gives me 5. So for the A coefficients, it's telling me that it's 5 times bigger, right? AC. Now that should be the same for B. So if I do 20 divided by 4, oh yeah, it also gives me 5. So what that's saying is I just need to take AB and multiply it by 5. That will give me AC. So I would write it like this. You can write it different ways, but this is how I'd lay it out. I'd say, right, AC is equal to 5 lots, 5 times AB. It's a multiple of AB. Therefore, you don't have to write a lot because it's only 2 marks, right? That means it's parallel. When vectors are multiples of each other, they're parallel. That's just the definition of it. They are parallel. If they are multiples, they are parallel. Now, a step further, because it's asked for a straight line, not just parallel, AB and AC, yeah, okay, they're parallel, but how do I prove that they actually are connected, that they create a straight line? Well, this is the easiest bit. They both have A in common, don't they? The point A. They both have them in common. So if you've got 2 parallel lines, they both go through the same point, then they must overlap fully, mustn't they? As in, create a straight line. So the second bit is that you just have to say that. Something like they share point A, or whatever point it happens to be in the question. In this case, it's A, in common. Or they both have point A, whatever you want to call it. Therefore, that means not only are they just parallel, because they could be parallel but just floating around separately, they go through the same point, so therefore they must actually create, oh, I just wrote straight, a straight line. That's all you need to know. If you're ever proving that they're parallel, they say prove these 2 vectors are parallel, find out what the vectors are, and then show that they have the same like multiple scale between both coefficients. And then if they actually ask for you to prove that it's a straight line beyond that, then you just have to show that, okay, not only are they parallel, they also have the same point, which normally you just look at it and go, oh yeah, both have point A, so clearly they cross through the same point. For circle theorems, how do you know when to write methods? They will tell you in the question. Yes, exactly. You said it says write a reason for it, like give a reason for each stage if you're working, or it says write down each circle theorem that you use. Normally it's only 1 mark, so you probably only need to write 1. You might have used 2, so write down 2. Obviously don't write down a random one, write down the one that you did use. But it will tell you. So that's the first part. I think part A there's alright. It's part B that's a little bit harder to get your head around. So D, E, and F are 3 points on a straight line, such that, so already we're saying that they're on a straight line, right? Just bear that in mind. In this case, they are already on a straight line. D to E is 3E plus 6F. E to F is negative 10.5E minus 21F. Now remember, with vectors, the positive and the negative tells you a direction as well. So find the ratio of the length DF to DE. I, in this case, like to just sketch it because I feel like otherwise it's really hard to visualize. Now, if we read this correctly, we've got D to E. D to E is obviously the smaller one. That's the most obvious thing, I think, to start with. So let's say that's D, that's E. This direction, we've got 3E plus 6F. Now, how do I interpret E to F? It's obviously bigger, you can clearly see that, and they're on the same straight line, so they are multiples of each other, exactly. But it's clearly a bigger version, but the other thing is the negatives. DE was positive, wasn't it? So I've drawn it in, well, it doesn't really matter which direction, but I've drawn it in that direction. E to F is then negative. So it's on the same straight line, but it's going the wrong way, as in the opposite direction, and it's obviously much bigger. So do you see how that's how I've interpreted it and said, right, well, it's not D, E, F in that order, it's D to E and then back to F. So that's why I think that one's a little bit complicated. Now the whole of that from E to F is this one. Not just D to F, right? Or little points. This is obviously not to scale, but just a rough idea. Just so you can visualize it. Okay, now they've asked for DF to DE. Now I know what DE is, but I don't have DF, do I? What I've actually got is EF. I've got the whole thing, haven't I? That's what I've got here. So the first thing I would probably do is just work out as a vector DF. So going D to F, I would probably have to, if you imagine walking along a line, I would go this direction, so to E. It's meant to be a 6. And then I would go the other way. Effectively, we're just adding them up. You don't have to think about it the way I've just said, but we're effectively just adding them. These, let's collect the like terms. So what would that give me? Minus 7.5 E minus 15F. So that is the green bit. Now I want to know the ratio between the top two. And as we said, they're multiples of each other. So just have a look, compare the coefficients. Don't worry about the negative now, because a ratio doesn't care about direction, does it? It's just size, scale. So ignore the negative, but 7.5 divided by 3, those are the coefficients of E. What does that give me? That gives me 2.5. It should obviously be the same for the other one. You don't technically need to check, because I know it's a straight line, so I know they're multiples. But 15 divided by 6 would be the exact same answer. They're both, the scale is 2.5, sorry. Now, how do I make that into a ratio? Well, the 2.5 is obviously the bigger side, isn't it? I mean, I can see that clearly. So DF to DE, if DE is just 1, then the other one would be 2.5. Now, do they accept that, or does it need to be? It doesn't say it needs to be a whole number, does it? It doesn't say that they need to be integers. This question 15. Yep, they said they would allow this, or obviously if you want it as whole numbers, as integers, it'd be 5 to 2. So any kind of equivalent, as long as it's in a ratio and obviously you've got the correct things on the right side of it, the bigger one should be on the left. And that's fine. Yes, I'll put 2 because that looks a bit nicer, doesn't it? That one I think is just a bit harder just because you have to figure out the way it's laid out. But beyond that, the actual maths isn't that difficult. So that's 3 marks, 5 marks in total for question 15. Question 16. A first aid test has 2 parts, a theory test and a practical test. The probability of passing the theory test is 0.75. The probability of passing only one of the 2 parts is 0.36. The 2 events are independent. We need to work out the probability of passing the practical test. So this is just... Oh, you said one more time. Just go back quick. Sorry, I think the chat's a little bit behind where I'm at. Did the diagram make sense to you? Because that's kind of the key bit. Or was it... Is it the diagram that didn't make sense, or was it the bit after that that didn't make sense? so I can kind of narrow down. Just waiting for the lag. Yeah. Oh, for part A. Yeah, the summary for part A is just that if you're wanting to prove that it's on a straight line, first of all, prove that they are parallel. What that means is you have to prove that they are multiples of each other. So just figure out what scale there is between the A coefficients. If it's the same scale for the B coefficients, then yes, they are parallel. And if they have the same letter, do you see how they both got A in this particular case? It might be a different letter for a different question. But if they both got the same letter, then they're obviously going through the same point. So imagine two parallel lines, but they actually go through the same point, well, they obviously have to create a straight line. Yeah. But I have got, again, like, if there's any of these paper that you want to kind of go through in more detail, more questions like it, a lot of these I have got videos on. So like, for example, I've got videos on vectors where I've gone through vector questions, just like these ones. So that might be helpful if you have a look at those as well, just so that we can obviously get through the paper, and then I can obviously answer some questions at the end as well. But have a look through my channel, you'll see that I've got vectors questions where I go through it in more detail. That might be more helpful to you as well, just so that we can get through the paper as well. Alright, so this one, I am thinking about it as a probability tree. That's just how I like to look at it. So first of all, you have to do the theory. Now we know the theory pass is 0.75, so I might as well fill that out. So therefore, if I fail the theory, what's the chance of that? Well, it has to add up to 1, so that would be the other 0.25. That bit's fine. Then, either way, we have to do a practical test. Can spell it, there we go. So pass, the practical, we don't know currently, do we? We don't know the fail, we don't know here, we don't know here. So this is where, when there are bits that are unknown to you, this is where, again, I like to add in algebra. That's just how I like to look at it. Let's say that the probability of passing the practical is x. The probability of failing the practical, I'm not just going to put y. Try not to put two letters if you can avoid it, because oftentimes there's only enough information to create one equation. And if you've only got one equation, you can only solve for one letter. So we've just done here, if the pass was 0.75, then I just did 1 minus 0.75 to get the fail. So for the fail, it would be 1 minus x, wouldn't it? You see how I can write them both in terms of x? And because they're independent, it means whatever happens in the theory test, it doesn't impact the practical test. So they're the same exact probabilities. That's how I would lay it out. Now, the key part here is this sentence. The probability of passing only one of the two parts is 0.36. So imagine you were asked to work that out. What is the probability of passing only one of two parts? Okay, I could pass the theory, but then I'd have to fail the practical. Or the other option is I could fail the theory and pass the practical. Now imagine you're working through a probability tree. When you work through them, we always multiply between the branches. So for the blue option, that would be 0.75 multiplied by 1 minus x. And then for the green option, that would be 0.25 multiplied by x. And then when you have probability trees, when you've done multiple options, so here I've got two possible options, haven't I? When you've got multiple options, that means that we have to add them, because it's either the blue option or the green option, isn't it? One or the other. And then that is what is equal to 0.36. So do you see how I've created an equation? And that's why I only wanted to use x and not a second letter, because I only had enough information to create one equation. So from here, let's expand it. So we get 0.75 minus 0.75x plus the other 0.25x. It's just a bit annoying because we've got decimals, but that's okay. You can obviously multiply the whole thing by 10 if you wanted. I might do that in a minute. Let's see. So this would add together to give me minus 0.5. Hopefully the rain isn't too loud. X. Now, to solve it, I want x to be positive, so I'd probably add the x to the right-hand side. And then I would take away, so move the 0.36 across, take it away, which gives me 0.39. As I said, you could multiply by 10 if you don't want to deal with decimals, that's fine. Or well, I guess by 100. Gonna let me move it? Yes. Now, this might be the tricky bit. Technically, yes, divide by 0.5. Hopefully you know that dividing by 0.5 is the same as dividing by a half, which dividing by a half is the same as timesing by 2. So I'm just going to double it. So yes, you are right. If you get 78, but did you leave it as 78 or did you say 78%? Because if you just put 78, I don't think they'd accept it, because obviously probabilities have to be less than 1. If you put 0.78, fine. If you put 78%, fine. If you put 78 over 100, that would be fine. Let me have a look. Or equivalent. Yeah, if you just put 78, I don't think they'd accept it because it has to be a probability. So any kind of equivalent of this, 78%, like that, that's fine. 78 over 100 would be fine. You could obviously simplify that to, you might have made it into fractions, that's also fine. Any kind of equivalent is okay. Could we use fractions? Yes, exactly. You can use fractions up here. Like instead of using 75, well, 0.75, you could use 3/4 and 1/4. That's also okay. It might be a bit tricky because 0.36. If you're happy to convert that into a fraction, then great. That's okay. So yeah, that's 4 marks for that one. That's how I would do it. Just create an equation. Whenever there's unknowns, I try and create an equation, I think. Okay, question 17, we've got y is directly proportional to the square root of t. We've obviously got our matching pair. Then we've also got t is inversely proportional to the cube of x. Again, matching pair. Find a formula for y in terms of x. So for proportion, most of the times it's 3 steps. Here it's just those 3 steps, but twice, because there's 2 different relationships. So step 1 is to write the correct formula. So if for direct proportion, it'd be y equals k multiplied by this bit, which is the square root of t. K is multiplied by that. You can do the other one at the same time. Oh, hang on. You could do the other one at the same time if you want. So the formula for the second bit is t is, whenever it says is, that's where you put the equals. Inversely proportional, that is where we do the fraction k over x, or in this case, x cubed. So it's quite hard to remember that, because sometimes I think you put k in the denominator, but you don't. K is in the numerator, the x, or whatever it is, in this case x cubed, is in the denominator. So those are my 2 formulas. Step 2 is then you have to sub in, without colouring it in, nope, sub in the matching pair so that you can work out what k is. Now actually what I probably should do, because I've got 2 relationships here, obviously k is not the same for both. So mathematically I should use a different letter. So I'll put c, but just think that that's the same thing. So sub in y is 15, step 2. And I don't know what k is, so that's what I'm trying to find. The root of 9 is 3. So you can see I could solve this quite easily, divide by 3. So for the first formula equation, k is 5. It's obviously not 5 for the second one. That's why I changed the letter, just to distinguish. I like to therefore write out the same formula, but with the number, just so I've got just y and t in that particular case. Same over here. Sub in your matching pair. So t is 8. And 2. Okay, so we've got 2 cubed, which is 8. If I multiply it across, I get 64. So you see how this one is 64? They're not equal. That's why I put a different letter, only for that reason. Oh no, it's not y. T is 64 over x cubed. So I've got both of my relationships there. That's done. That's step 1 and step 2. Step 3 is actually answer the question. I didn't even have to worry about what the question was until this point now. So the question was, find a formula for y in terms of x. That means, if you translate that, that they want a formula where it's y as the subject, and then you've obviously got numbers, but everything else in terms of letters is just x. So what they're saying is they don't want t. So what I would do, is just quite simple, just substitute in all of this where it says t. So y equals 5 And instead of root t, I'm going to put all of this. You see how now I've got y as the subject, and then I've only got x as a letter. I don't have t anymore. I obviously don't have k or c or anything. So that is a formula for y in terms of x, but they also do want it in its simplest form. So at this point, I just need to simplify. So square rooting, when you're square rooting a fraction, you can square root the numerator and the denominator separately. So 64, if you square root it, is obviously 8. But how you're thinking, well, how do I square root this? You could, I think you can leave it like that, do you know? I think you can leave it like that. I was thinking about fractional powers, but I don't think it's necessary, to be honest, because it's not really that much more simplified. I would leave it like that. I wouldn't even bother square rooting, because it doesn't really square root, does it? Just at least square root. Oh yeah, square root the 64, and then we can multiply the 5 and the 8, can't we? When you have a whole number, so the 5 is a whole number, isn't it? And you're multiplying by a fraction, it only multiplies the numerator. So not the denominator. Otherwise it would just cancel out. So that's what they mean by simplify. I wouldn't bother simplifying the root x cubed. Won't worry about that. There are some things where you think this is a non-calculated. It's a bit of a step too far, isn't it? They're not going to ask me to do something that complicated. So yeah, that's it. That was technically set 3. So the question, and that is 4 marks. Okay, question 18. We've got work out the value of 5 and 4/9 to the power of -1/2 multiplied by 4 2/3 over 2 to the power of -3. You must show all your work, obviously. Questions, you want to show all your working. Okay, so what I would do here, because we've got mixed numbers, is I would just make them into improper fractions just to start with, because currently the numbers are a bit random. So to convert into an improper fraction, I multiply the 5 as in the whole number by the denominator. So 5 times 9 is 45, add 4, 49 over 9. That is a slightly better set of numbers for me. And then this one, 4 times 3 is 12, add 2 is 14 over 3. That's a bit random still, but I guess we don't need a bracket there. And then the 2, I would convert that into a fraction as well. So the 2, the power of -3, sorry. The negative is the reciprocal, isn't it? So flip the fraction upside down. 2 as a whole number, any whole number, you can write it over 1. So obviously if you flip it to make the reciprocal, it is 1/2. And then obviously you then need to cube that. Okay, this top thing here, we've just said a negative power is where you flip it upside down. So I might as well flip it upside down. Then I've got the power of 1/2. Just leave your 14 over here for, oh, that's not an equals one. Leave the 14 over here for now. I thought the 14 over 3. This one we just said cube it, so 1 cubed is 2 cubed is 8. Okay, the power of 1/2 we should know means to square root. So if I square root, I get 3. That's why I said I like the numbers better, because I could see that I was going to square root 3 over 7 times 14 over 3. Hopefully going. We've got rid of all our powers. When I multiply these together, obviously I'm multiplying across, aren't I? Like numerator, numerator, denominator, denominator. Oh, want to be down there, yes. And the 3's would just cancel, wouldn't they? There's no point in me multiplying 14 by 3 and then 7 by 3 if I'm then going to try and simplify the fraction and divide them both by 3. So those would just cancel. You would end up, purple still, 14 over 7 divided by 1 over 8, which you could divide it straight away, but that 14 over 7 will simplify beyond, won't it? As in 14 divided by 7 is obviously 2. I'm doing 2 divided by 1/8. We're almost there. That's the same as keep, flip, change, isn't it? Like if I write it like this, keep, flip, change, keep the first one, flip the second one, change it to a multiply. 8 over 1 is the same as 8. Either way, you should get 16. However you've kind of worked through it, you should get 16. Yes. Have a look at the chat. 16. Oh yeah, the 3 dots that I did on the last question just means it's just a very quick way. This thing, like, it makes it horrible. It's meant to make it like a triangle. This thing here, like a little triangle, but in 3 dots. That just means therefore, because I can't be bothered to write therefore. So I just use the 3 dots a lot in math. Yeah, you've just said in the chat. Yeah, perfect. 16. You also got 16. Okay, 4 marks for that one. Question 19, we've now got algebraic fractions. So solve 1 over 2x minus 1 plus 3 over x minus 1 equals 1. Give your answer in the form p plus or minus root q over 2, where p and q are integers. When I look at this, I can already see A, it's going to be a quadratic. B, I can't factorize because you can't factorize and get surds, right? So I'm thinking it's going to be a quadratic. When I solve it, I can't use factorizing. I have to use, well, you could complete the square, but I probably wouldn't. I would use quadratic formula, which is on your formula sheet, and you just simplify it. So sometimes you look at questions and you can kind of get a rough idea of where you're going to get. That's what my evaluation of this question is so far. So we're coming back to cross multiplying again that we mentioned previously. As I said, you can do it in multiple steps if you find that easier. I like to just do it all in one step because I kind of know what pieces are going to go where. When I solve an equation, I don't want to have A, fractions, and B, even less, x in a denominator. So I have to get rid of the fractions. The way we get rid of fractions is we multiply by those denominators to cancel them out. So I have to multiply, first of all, everything. So this is a term, this is a term, and this is a term, right? All 3 by 2x minus 1. So all 3 of those multiply by 2x minus 1. And then that would cancel out the first denominator. Then the second denominator is different. So I'd have to multiply all 3 of those again by x minus 1 to cancel out that one. Now, personally, I would do that all in one step. You can do it in multiple steps if you find that's easier. That's absolutely fine. So I know that when I multiply by x minus 1, it's going to be multiplied by 1, so that's just x minus 1. And the 1 over here, x minus 1. And obviously it cancels it on this one, right? That's just not there anymore. Then when I multiply by 2x minus 1, I have to multiply, well, first of all, it cancels out here, right? It's not there anymore. Then I have to multiply it by 3. So do you see how I get this bracket? And then I have to multiply it at the end as well. So I know it's going to end up like this. As I said, if you want to do it in multiple steps, that's fine. Now I've at least got everything on one kind of line. I'm going to expand everything and simplify. So do all of your expanding and simplifying, collecting the like terms, all of that. We've got double brackets here. 2x squared minus x minus 2x. Be careful with the negatives and all of that. So easy to mistakes. We've got 7x minus 4 on the left. 2x squared minus 3x minus 1 even on the right. And then because I can see that I've got a quadratic, i.e. the highest power of x is x squared, so therefore overall it's a quadratic. The way we solve quadratics is they have to have all of the terms on one side of the equation. Now I'm going to move everything to the right because I want my x squared to be positive, and it already is on the right hand side. So I'm going to move the terms from the left to the right. So subtract 7x, so 2x squared is still there, minus 3x minus 7x is minus 10x, and then add 4 would be plus 3, and that should equal to 0. I made a mistake there. I feel like oh yeah. I was going to say, I think I made a mistake. That's what I was just saying. It's so easy to make a mistake. Minus 1 times minus 1 is obviously positive 1, right? So plus 1. Plus 1. Just be really careful. So when I add 4, I get 5. There we go. Okay, so we've got our quadratic. Now, normally, especially in non-calculator, I'd be like, okay, great, quadratic, factorize, 2 brackets, whatever. You can try, obviously. There's no point trying because I can see the format of my answer is like this. So there's no way like if I were to factorize it, I get either whole numbers or maybe a nice fraction or something like that. This is not a nice fraction. It's obviously not a whole number either. So I'm not going to do that. I am going to use the quadratic formula. So if you don't know it, that's fine. It's obviously on your formula sheet. I'll write it over here. Minus b plus or minus the square root b squared minus 4ac over 2a. Obviously a, b and c are in the order. As long as you've written it in correct order, those are a, b and c. So subbing it in, so to work out x, I want minus b. Now be careful because it's negative b in the formula. I've already got a negative b, which means it's double negative, so that would become a positive. Plus or minus, technically minus 10 squared, which I know would become positive. Take away 4 times 2 times 5 over 2 times 2. And then from here, I'm just going to simplify it until I get to something that looks like it. Basically when I get a denominator of 2. That's what I'm going to do. So the 10 can stay there for a second. Squaring negative 10 is positive 100. Take away 4 times 2 is 8 times 5 is 40 over 4. And then just keep working through it. So that would give me 10 plus or minus root 60 over 4. Now you might think, yeah, that looks quite nice and simplified. But as we just said, the denominator here is 2, not 4. So it tells me I need to do a bit more. And what that is I need to simplify the surd. Remember how you simplify surds. You break it into 2 surds, 2 factors. One of them has to be a square number though. So square number factor of 60, I think it's just 4. I'm trying to think if there's a bigger one. I think 4 is the biggest one. No, 4 and 60, 4 and 15. And then you can square root the square number, so 2 root 15. There we go. The 10 plus or minus 2 root 15 over 4. Then do you see, ignore the surd, but out of these 3 terms, they're all divisible by 2, aren't they? I can simplify them all by 2. Down here. That would give me 5 plus or minus, technically 1, but you don't need to write 1. Root 15 over 2. That would be your final answer. That's the format that they wanted. Okay. Question. 5 plus root 15 over 2. Yes, you're. How do you deal with a fraction in the square? Is that a completely separate question, or do you mean because I mentioned earlier that you could complete the square? Because if it's related to this question, I can go through it. Do you mean, or do you mean just like separately? Two questions left. Chat before I move on. Yeah, you mean in this question. What calculations do you need to know? You need to know density. That's probably one of the key ones on, because you do get force, pressure. Get that one. Density you need to know. Prisms to know, because they will give you anything that's not on prism. So if it's a sphere, they'll give you that. If it's cone, they'll give you that because it's not prism, but prisms I would recommend. Okay, so if we were to complete the square here, because that's the other option, right? There are 3 ways, well, technically there's 4 ways to solve quadratics. 1, ideally factorize, put into brackets. 2, quadratic formula, which you often do with, obviously, a calculator. In this case, we could use it, we just had to simplify it rather than getting an actual decimal answer. 3 is completing the square, 4 is graphically, but obviously graphically you would only ever do if they actually told you to do it graphically. Don't just try and draw a graph if they haven't asked you to. So you kind of ignore that one. So completing the square, if I was to complete the square, it would be at this point here, right? So I would go, leave the 0 on this side so you can see. I would factorize out 2. I would only factorize it out of the first 2 parts, right? That's just me. So there's no need to take it out of the third part. You can, but I don't see the point. Then I would complete the square. So from there, we get square brackets, x minus a half of this. So unfortunately, yeah, I guess that's what you mean by the fraction. We're getting fractions here. You just have to be really good at fractions, I guess, is the answer to your question. You subtract this squared. So that would be a positive, but I'm subtracting it, 25 over 4. In the brackets, I still have 5 here. Expand it all. So 2x minus 5 over 2 squared, and then I would have to multiply the 2 by this as well. That would be minus 25 over 2. That would simplify to that. Plus 5. Obviously, I'd want to, I guess, add those together. So You could make it into a decimal because it's only 0.5, isn't it? It's not that hard. Or if you leave it as a fraction, then you would have to do 5. That would be 10 over 2, wouldn't it? Like if you make them have a common denominator, that would be 10 over 2. If I add those together, what's that? Minus 15 over 2? That's right. That's not, what is that? It's meant to be a 5. Minus 15 over 2. Well, that's completed the square version. Obviously that's much harder. That's why I didn't really bother doing it here. Then to solve it, I would probably add that across. Kind of unpick it, I guess. You see what I mean? Like undo that equation. Times it by 2. Sorry. Divide by 2, so actually that'd be 15 over 4, wouldn't it? I'm going to cancel it out, but it's not. I guess this is where our square root would come in, isn't it? I would square root both sides, but this is where you have to remember when you square root anything, you get plus or minus. You should have 2 solutions for any quadratic, unless they happen to be the same number, in which case obviously that's fine. And then I would add the 5 over 2. 5 over 2 plus this. Obviously, plus or minus. Root 15, I can actually square root the 4, can't I? So that would become 2. And then you see how you just end up with the same thing. Yeah. We have a look at chat. Yeah, you could do it that way. That's absolutely fine. I just think that's more work. I don't see that. How do you do the third thing? Root 4, root 15. So the third bit is where I'm simplifying root 60. So you see how 4 times 15 would make 60? They're factors of 60, but 4 specifically is a square number, which means it then square roots. 15 obviously does not square root, it stays 15. So that's just simplifying surds, that bit there. I kind of pulled it to one side. Do I also teach IIT and G? I don't know what those are, so I'm going to say no. Sorry, I'm not sure what. If you've just joined the live stream, you are welcome to, obviously at the, well, you can go backwards, but this will upload once I finish anyway. You can go back. If not, then you're in time for the last 2 questions, basically. Yeah, if your exam is calculator, I would assume that you are OCR. I might be wrong, but that's my assumption because AQA and Edexcel tomorrow is paper 1, which is non-calculator. I think OCR, I don't know if there are any others, but I know that OCR tomorrow is a calculator paper. So this wouldn't be very helpful. It would be better to look up OCR or whatever your exam board is. Yes, let me move it over. These are just 2 options, right? These are 2 options of working out. Zoom out. So it's whichever you prefer. Your options are, you either use quadratic formula here, or you complete the square. But as you can see, I feel like completing the square was just more working. Is this for IGCSE? It's not, but I would imagine it's not. If you're doing Edexcel IGCSE, it's not massively different because it's still Edexcel. The only thing is that IGCSE, you have 2 papers that are they're slightly longer, and you also have calculator for both. But it is kind of similar. It's not that far off. I would recommend you look up IGCSE specifically, though, just that you're really... Yeah, just that you're used to that one. Okay. OCR. What is your exam board? Because you should know that. I'm assuming it's OCR, like letters. Okay. I'm going to carry on. Last 2 questions. I think the last one is actually quite. Alright. The center of circle. Can't even read that. Let's try again. The center of a circle is the point with coordinates -1, 3. The point A with coordinates 6, 8 lies on the circle. Find an equation of the tangent to the circle at A. Give your answer in the form ax plus by plus c equals 0, where a, b, and c are integers. This is, I think, quite a nice question. For some reason, I feel like tangent is always one of the last questions, but this one is a very nice one. You just have to follow exactly the method that hopefully you can memorize. All right. So when we work out what you can do, I kind of recommend, again, I'm quite a visual person, so I like to look at it. You don't have to. If you're not a very visual person, then I'm saying right now. I like to sketch it out just really, really quickly. Don't waste your time perfecting it, right? I like to just quickly sketch it. So my center is -1, 3. So let's say roughly here. Again, it's not to scale. Let's say here. And then it goes through 6, 8. So I don't know, something like that, right? It doesn't have to be exactly to scale. So my center is about here. About there. And then let's say 6 across it. Let's just say it's here, right? This is A. 6, 8. So my tangent is there. Straight line. Something like that. You know, more or less. That. 1, 3. So the way that we work out the equation of a tangent is, it's obviously a straight line. The whole point of the straight line is y equals mx plus c. So I need the gradient, I need the c. I always start with the gradient. Now to find the gradient, we need change in y over change in x, as we said earlier. But we don't have 2 sets of coordinates on that line. So you have to start from the radius. That's the radius there, the one I've just drawn. Because I do have 2 sets of coordinates for that. That's 10. So the gradient of the radius, change in y over change in x, 8 minus 3 over 6 minus minus 1, which will give me 5 over 7. You can see I've obviously not drawn it super to scale, but you can see that it is positive gradients. That makes sense, right? Now, this is where we have to remember your circle theorem, that the radius and the tangent are always perpendicular, 90 degrees, so negative reciprocal. I can convert this gradient into the negative reciprocal. Oh, I can also see from my sketch that it should be a negative gradient. So if your gradient's already positive, make it negative. If it's negative, make it positive. And then the reciprocal, we keep saying about reciprocals, is where you flip it upside down to 7 over 5. So I've got the gradient for my tangent. I put t for tangent, r for radius. So now I've got y equals negative 7 over 5 x plus c. The only thing then I'm missing is the plus c, which is the y-intercept. Now I can see that it's somewhere up here positive, but I obviously can't, like, I can't look at my diagram and actually guess, because that's obviously not going to be accurate, right? So I'm going to actually work it out. Now the way we always work out the plus c is you just substitute in a set of coordinates that are on the line, which is 6, 8. I've got those. So remember that 8 is for y, don't sub in 6 there. It can be quite easy to put the 6 first, but not. The 6 is for x. Again, a lot of fractions basically that we have to work around here. So when you're multiplying a whole number with a fraction, it only multiplies the numerator. So that would be 7 times 6, 42. Why that went out of my head then. Over 5 plus c. Now I'm going to add it to the other side. Now when I want to add it to 8, I'm going to need to have a common denominator again. So 8, currently any whole number, I keep saying this, is over 1. So to make it a common denominator, I would have to multiply this one by 5. That would be 40 over 5, wouldn't it? Plus 42 over 5 is c. That is 82 over 5. That's how I would work it out. I guess you could use decimals if you wanted. I don't really want to, so that's why I've used fractions, but I'm just going to leave it like that now. So let's rewrite it. We've got y equals negative 7 over 5 x plus 82 over 5. Now, that is the tangent, but remember to double check what format they want it in. So we want ax plus by plus c equals 0. First of all, everything on one side, but also they're all integers, they're all whole numbers. So when you get that, to make them all whole numbers, you see how they both have the denominator 5? So in order to get rid of a fraction, in order to make them whole numbers, I just multiply across the whole equation by 5. So that would also make it 5y minus 7x plus 82 x. So they're all whole numbers now, and the last thing was we wanted everything on one side, so I'd probably make it so that x is also, like if I moved the 5y, it would be negative, so I think it'd be tidier, like neater, if I moved everything to the left. I think they wanted x first, so 7x plus 5y minus 82, it's fine if the number is negative, but x and y are positive, equals 0, that's just formatting at the end, that's all that is. So yeah, it's a pretty straightforward tangent question. Just the last bit, you had to format it. That's format. Okay. Look at the chat. Yeah, Cambridge is an international exam board. Yeah. Could be that, I guess. But this won't be, yeah, if you're doing Cambridge, that'll be different. But you can probably look that up on YouTube. People going through those parts as well, if you want specific. This one is from 2022. It's not my predicted paper. However, I have got a predicted paper that's not a live. It is just a video, which I uploaded yesterday. So if you have a look at my channel, it should be the second video. You can have a look at my prediction if you like, which would be based on Edexcel though. So, all right. Checking if there's any questions. How come the 8 is 8 over 1? Because 8 as a whole, any whole number, which 8 is a whole number, if you want to make it into a fraction, which I needed to do because I wanted to add it to another fraction, it's over 1. So any whole number, you can just put it over 1. Because if you did 8 divided by 1, it would still be 8, wouldn't it? It'd be the same thing. And then I had to, in order to get a common denominator so I could add them, I had to times top and the bottom by 5. That's where that came from. How come we don't multiply the 42 and the 1? Just leave. Yeah, so the 42... Going to, how come you don't multiply the 42, 1, and just leave it 42? Because the lowest common multiple between 1 and 5 is 5, so if it's already... Like, if one of your fractions already has the denominator, which is the lowest common multiple, you don't have to change that fraction. If they were both different, then yeah, I'd have to multiply both. But because one was already, it already had the denominator 5, and my common denominator was going to be 5, I didn't have to change the 42. That was a bit easier. This isn't iGCSE, no, this is normal GCSE. If you're doing Edexcel iGCSE, this might be kind of similar. Not that far different, but it's technically not iGCSE. When I times it will always be positive. Well, which bit are you referring to if when I multiply it's always positive? The 42 over 5 became positive because I added it, like, to the other side of the equation. That's what you're referring to. Let's see if you're talking about, and then we'll go on to, there's just one question left. It is, I think, the hardest question though. Yeah, okay. Okay, that was 4 marks. Final question. This is, I think, one of the hardest questions. I mean, again, it's one of those things where I feel like the maths necessarily isn't... Yeah, it's a little bit hard, but I think knowing what to do is the hardest bit. Figuring out what to do is the hardest bit. So, we've got, the diagram shows 3 circles, each of radius 4. The centres of the circles are A, B, and C, such that ABC is a straight line, and A to B equals B to C, which is 4 centimeters. So, like, you could, they're all in the same level, I mean, and the distance here is the same, it is 4. Work out the total area of the 2 shaded regions. Obviously, give your answer in terms of pi. They're not going to make you work out what pi to exam unless it's an estimate. So what I did here, I think when you've got things like this, I'm always looking for triangles. What I would suggest, always look for triangles. So color code a bit, I think. If I draw a line from A to B, that is the radius of circle A. It's also the radius of circle B, isn't it? See that? And then if I draw a line from B to this corner here, oh, it's not really a corner, but you know what I mean, where they intersect, that is the radius of circle B still. So the purple lines are both 4. They're both a radius. And then if I do the same thing, get a different colour though, I had A to B, no, that's 4. We know that that's the radius of A as well as B. And then if I do this line, this is also the radius of A. So you see how then they're all 4, which is an equilateral triangle. Now, how is that helpful to me? Because equilateral triangles have angles 60 degrees. So at least I've now got an angle to work with, not just sides. So let's think about the order I would do this in. Okay, I'm going to leave that there. We'll look on, obviously the other side is the same, right? And below is the same. There's like 4 triangles that are identical. Okay, I'm just going to draw here. Let's work with this as if it were a sector now. Think of it as a sector. That section there. That's also going to be 60 degrees because, as we said, if I were to draw a line here, it would be the same equilateral triangle. There's a sector there. I know it's 4 and 4. So let's work out the area of the sector. We should know that formula. Yeah, I don't think they give that in the formula sheet. Yeah, area of a sector. Someone was asking what formulas. Area of a sector and then arc length. You should know those. So area of a sector is the area of the whole circle, which is pi r squared, multiplied by the angle of the sector over 360. Now that's why I wanted to know the angle. So in this case, we know that the radius is 4, and we know the angle is 60. To be 3. So just go through and kind of rearrange that, simplify it. That'd be 16 pi. This would simplify if I knock off the zeros to 1/6. That's not a 6 at all. 6. So 16 over 6 pi. You could simplify that further if you want. Base now. What's that? 8 over 3. If I highlight it, we can. What is what? That is 1 sector. Right, this bit here. Now there are 4 of those, aren't there? See how there would be 4? There'd be 1 down here, 1 on the left, or 2 on the left, 1 up and 1 down. There would be 4 of those. So we could times it by 4. That would be 4 times 8 is 32 over 3. Okay. That's all 4 sectors. Now, I then have the bit that's then missing is like this little slither here. I guess we call that a segment, don't we? That's why I'm going to come back to the triangle now. That segment there is the same as this segment here, isn't it? They're all the same. So if I can work out the whole sector, which I've got, 1 sector is 8 over 3 pi, and then I subtract this triangle, then it leaves me with the segment even, doesn't it? Segment. So area of a triangle. Now this one, I think you would have to use the trigonometric area of a triangle because we don't have a vertical height. You probably could work it out if you use Pythagoras, but I can't really be bothered to do that. So I'm going to use the half AB sine C. That's on your formula sheet. Now, that's obviously the angle, and then there's 2 sides between it. So half times 4 times the other 4 times sine of the angle 60. Now remember that for the non-calculated paper, you're supposed to have memorized certain values. Alright? So certain values, in this case, sine 60 is root 3 over 2. So you do half times 4 is 2, times 4 is 8. What have we got here? Said root 3 over 2. And then obviously if you multiply that, you get 4 root 3. Okay? 4 root 3. Oh, thank you to someone who has just sent something in the chat. That was really good of you. Thank you. That's lovely. Alright, so this is my triangle. Let's color code that separately. So we'll go with green. Get the tidy. There. That's what that is. So segment. The area of, sounds like sector, but I'm not saying sector, I'm saying segment. The orange bit would be the whole blue bit, 8 over 3 pi, minus the whole green bit, wouldn't it? That's not a fraction. Yeah. Now, I can't simplify that. I'm literally just going to leave it like that. It looks kind of messy and annoying, but you know what I mean? I've got surds, I've got pi. I'm not going to work that out myself because it's a non-calculated paper. So that's the orange bit. I like that. So we can keep track of what is what. That's the orange bit. Okay, finally, where are we actually going with this? If I want to find the shaded region, I could work out the whole, I'm trying to ignore all of my diagrams, the whole of circle B, which was that center circle, and then I could take away, I've got 4 sectors, and I've got 4 segments, haven't I? So I could take them away. Yes, someone who's asked about 5 over 2, I'll go back to that once I finish this question, alright? So it's just all in, at least I'll carry on with this and I'll go back to it. Okay. So, the area of circle B as a whole, just pi r squared, isn't it? Radius is 4, so that is 16 pi. That's the whole of circle B. Then I want to take away the bit that isn't shaded. Subtract, as I've just said, I've got 4 sectors, which I worked out here, didn't I? That's 4 lots. Over 3 pi, and take away 4 segments. So let's work that as well. If I times that by 4, I get 32 over 3 pi minus 16 root 3. Take away 32 over 3 pi gets minus 3. Obviously that's messy, right? I don't want to leave it like that, but that's where I'm getting to. I'm just going to have to go away from the question so that I'm actually following some kind of logic here. Okay, let's see. So these have got both pi's, they've both got a common denominator, so I can, that would be 64 over 3, wouldn't it? Pi. And then just be careful here because you're doing a double negative. You see how that would be a double negative? So minus 16 root 3. Okay, these are both pi's, so they're like terms. If you think about algebra, they're like terms. So I'm actually going to work those out. This is, again, we're coming back to this over and over. If you ever want to convert a whole number, an integer, into a fraction, you just put it over 1, because that is still the same number, isn't it? Now, the lowest common multiple, because when I subtract fractions, I need to have a common denominator. The lowest common multiple between 1 and 3 is 3, so I don't need to change this fraction, but I do need to change the first one by multiplying the top and the bottom 3. That would be 48 again, 16 times tables, I keep saying that comes up. And now, do you see how I could take them away? 48 minus 64 would actually be negative 16 over 3. Pi plus the other 16 root 3. There. Now, I would probably just write it the other way around because, just for the sake of the fact that I don't like to have a negative start. But it doesn't really matter, right? It's the same thing. This is my final answer. That's the most simplified I can get. Okay, that is, yeah. There's a lot to keep track of there. I think that's why it's hard. There's a lot to keep track of there. But that is a, obviously, 5-mark question. So that would be the shaded region here. 16 root 3 minus 16 over 3. So the last bit is here. I know I've not really drawn it in very logical order, to be honest with you. That's fair enough. I did the area of circle B, which is just pi squared. Pi. And then I subtracted 4 of these blue segments, because if you imagine it here, there's a segment below the blue one, there's a segment to the left, and then there's one, like the orange and the green add together to make a segment, so that's 4. Sorry, add together to make sectors, so that's 4 of them. But there's this little bit here, this little slither, this little slither, and this little slither. There's 4 of those which are segments, which is the orange. So I had 4 of the blue and 4 of the orange, which I then subtracted from the whole circle, and that should leave me with the shaded region. And then from there it was basically just simplifying like fractions effectively. The last bit is just fractions. That answers your question about the last bit, but you can see here that's 5. And that's the last bit. You were asking about the flip. So here, when you have 2 lines that are perpendicular, so because of circle theorems, we should know that a radius and a tangent are always perpendicular. That's the radius, and this here was the tangent, wasn't it? They're perpendicular. Whenever 2 lines, straight lines, are perpendicular, you can convert the gradients between each other. You can flip between one and the other by doing what I would call, well, not just me, obviously it is called this, negative, another iron, reciprocal. So there's 2 parts to that. The negative means you swap the symbol. So it was already positive, so I made it negative. If it was already negative, I would make it positive again, if you know what I mean. So you see how, obviously if you have 2 perpendicular lines, they're crossing through each other, so one is going up and one is going down. So one's a negative gradient, one's a positive gradient. And the second part is the reciprocal. So if you have a fraction already, that's why I kept it in a fraction. I don't like to use decimal questions. It's easier to have a fraction. You flip it upside down. The reciprocal means flip the fraction upside down. It's just a fancy way to say that. So that's why we not only made it negative, but also then flip. Just because of perpendicular reciprocal. That's that bit. So yeah, that was all of that paper. That was, as a reminder, the Edexcel June 2022 paper 1H, so higher tier. Somewhere should have. I remember where I've saved the spreadsheet we were talking about earlier. Saved it somewhere. A quick look. Obviously, that is the end of the paper, so leave the live video, but I will have a look for it just in case I can. If not, then I'll have to look for it later and post it as like a like a post. You can see a screenshot, but it is in my other videos as well, where the grade boundary. Yeah, I have the old version. I did update it though. Got last year's. video from up on the screen. Strange. Oh, there we go. Found it. Very blue, but I'm going to print the screen. Because you'll read it. It's just this will actually upload later this week, so you'll be able to see it. There we go. That's what I was looking for. I'll have to find the actual original spreadsheet so it looks a little bit nicer, but you can read that. This is for Edexcel, right? So AQA, if you're doing AQA, just ignore what I'm saying. This is Edexcel average grade boundaries, right? I've worked out the average grade boundaries. Okay, so this is not to say that they won't be a higher grade boundary this year, a lower grade boundary this year. This is the average, I think, yeah, here I've said from 2017 to 2025. So it's a bit skewed because of COVID, I guess. But just so you've got a rough idea, you're looking to get a 7. Your total amount of marks you would need to get is roughly 136, so roughly 45 per paper, which is only 56%. Now, to be safe, because as I said, it might be a bit higher, it might be a bit lower, to be safe, maybe round it up, just to cover your base. So if you were saying, right, I need to get a 7, maybe try and aim for like at least 50 on each paper, maybe 55, just so that you're really safe, because I don't want to say this and then this year the grade boundary is higher, and you'll be like, oh yeah, but you said the grade boundaries were going to be lower. I don't know what they're going to be, obviously, I have no idea. But take these numbers and round them up a bit, just to cover yourself, right? So you can see there for 4, 5, 6, 7, 8, 9 for higher tier, and for foundation, if you're looking for a 4, 46%, 46 marks per paper, that's 57%. So again, round that up to like 50, 55, just to be safe, just to cover yourself. So if anyone was looking for the average Edexcel grade boundaries from 2017 to 2025, those are what they are. I don't think that includes November last year. Yeah, that won't. Yeah, I don't think it includes November because I'm not sure if they would have released. Yeah, they might have done. But I updated this like a month ago, so it's with the most up-to-date information that I had. So I'm just going to keep repeating it. If you're using these, just to give you kind of an idea of what you need to aim for, round them up just to be safe. Because there are obviously some years where it wasn't 45, for example, it might have been much higher than that. So just be really careful, just round them up, and then you've got a good idea of something to aim for. But I think you'll find, particularly for higher tier, that the grade boundaries are a lot lower than what you might think. So whoever was asking how many marks can I lose per paper to get a grade 9, I said as a guess probably 10. So I think that's a safe guess, because here you can see it's 14. But obviously, as I said, it might have been a grade boundary that was higher one year. If you say maybe 10 per paper maximum, that was probably a good estimate. Safe, maybe 8 or 10 per paper. That's a safe bet if you're looking for a grade 9. If you're looking to just pass, but you're doing higher tier, you effectively only need to get 20%, which is insane. But yeah, so maybe round that up. Maybe say, okay, instead of 14 marks per paper, I'm going to aim for 20 marks per paper, and then you'll probably be quite safe. So yeah, you can screenshot that. As I said, I know it's quite blurry, but this will be uploading. I have a video uploading tomorrow afternoon, actually. This is, when you look through the video, you can screenshot it from there. It should upload a little bit of this. And otherwise, I'll try and see if I can actually find the original spreadsheet that I did use. Because obviously the spreadsheet will look a lot clearer than this, but I've saved it. So right now that's that. But yeah, so that is everything for today. You can obviously go back and look through. I've done other live videos yesterday, last week, if you want to have a look at those. If you just want to rest the rest of the evening and just prepare yourself mentally for tomorrow, that's also absolutely fine. If you want to look at a predicted paper, I have my own predicted paper that I uploaded yesterday. that you can have a look through as well. If there's any specific topics that you want to look through, again, check if they're already in my backlog catalogue of videos. I might have done specific videos on certain topics that came up in this paper as well that you can look through. Completely up to you, but best of luck to everyone who is going to do their paper one, whatever exam paper you're doing tomorrow for maths. Just, I think the most important thing is to stay as calm as possible. Try not to get in there and panic, because that is worse, isn't it? Because then you might not answer the questions as you actually capable. Try and stay calm if you can. I know it's a stressful environment. Try and just focus on what you're doing, time you've got. Keep an eye on the time. We don't want to run out of time, so keep yourself moving. If you're stuck on a question, leave it. Okay, just leave it, move on, try and get marks elsewhere, right? And then come back later. The other thing I was going to say, yeah, my other tip is to make sure you write down something for every question. I don't care if you think it's stupid, if you're like, oh, I'm going to think it's really stupid if I write this. They're not judging you, they don't know who you are, right? So it doesn't matter what you write, just as long as you're not contradicting yourself, as long as you're not saying one thing and then you're working out something that's completely the opposite, then it's fine. Just write down anything that you think might be relevant if you're not sure on how to answer the question. Don't leave it blank. Write down anything you think is relevant. If it's a formula, if anything to do with the topics you can figure out, even if you're not sure, oh, I don't think it's meant to go this way, it doesn't matter. I'd rather you just wrote down something, because you never know where those method marks are going to come from, and you could get a higher grade from not necessarily answering the questions fully, but just from half answering all of the questions. You know what I mean? So yeah, try to stay calm, keep an eye on the time, make sure you write down as much as you can for every question is what I would say. Those are kind of my top 3. Yes, this video, this live, will be uploaded afterwards, so you can go back and watch it. I don't know how long it takes to do that. I don't know if it's automatic, but it will upload itself, yeah. And you can also, as I said, look through my previous lives. Like yesterday we went through June 2023. Last week we went through a few others as well, which were obviously closer to 2024 time. You can look at the more recent ones as well. Yeah, as I said, best of luck to everyone tomorrow. Thank you so much for coming to the live. Hopefully that's helpful. And I will be continuing lives. Obviously, I'll give you a bit of a break after paper 1. I think half term we'll continue with paper 2 and paper